Hello, chemistry students. Today we're going to talk about Dalton's Law of partial pressure. So Dalton's Law of partial pressure states that the total pressure of a gas is all the pressures of the individual gases added together. So at this example right here, if we need to find out the total pressure of this gas over here, which consists of helium and hydrogen, we must add up the individual pressures to find out what the total pressure is. So the pressure of just the helium gas plus the pressure of just the hydrogen gas will equal the total pressure. So what if the units are not the same in your pressures? Well, you will have to convert using dimensional analysis. You convert to the same units. If you want your answer in atmospheres, then you put all your answers in atmospheres. Now let's do an example calculation. There's a container which has oxygen, xenon, and helium in it. The total pressure is known to be 972 millimeters of mercury. If the pressure of helium is known to be 0.458 atmospheres, and the pressure of oxygen is 74.1 kilopascals, what is the pressure of the xenon in millimeters of mercury? So let's write down our variables. Our total pressure, which is P sub T, is equal to 972 millimeters of mercury. The helium pressure, which is P sub He, the pressure of just the helium, is 0.458 atmospheres. ATM is atmospheres. And the pressure of the oxygen gas, which is O2, is 74.1 kilopascals. And we are looking for the pressure of xenon, but we specifically want it in millimeters of mercury. Now if you notice, there's only one of these gases in millimeters of mercury, and that is the total pressure. We need to convert the helium pressure and the oxygen pressure into millimeters of mercury. Okay, so let's do that. So I'm going to convert the helium pressure into millimeters of mercury. So I'm going to use my dimensional analysis. Whatever units I have on the upper left, I always put on the lower right. And what I'm converting to goes on the top. So I'm converting to millimeters of mercury. Now I'm going to look at my star reference sheet to find out what the relationship between millimeters of mercury and atmospheres are. And I see that there is, for every 1 atmosphere, there is 760 millimeters of mercury. So my units cancel. I have atmospheres on top, atmospheres on bottom. They go away. 0.458 times 760 is 348 millimeters of mercury. Now I need to do the same for the pressure of oxygen. I'm going to convert my kilopascals to millimeters of mercury. So whatever units I have on the upper left, I put in the lower right. And I'm converting to millimeters of mercury, so I'm putting those units on the upper right. And I look at my star reference sheet to find out what the relationship between millimeters of mercury and kilopascals are. And I notice that there are 760 millimeters of mercury for every 101.3 kilopascals that there are. Now I'm going to cancel my units. I have a kilopascal on top and a kilopascal on the bottom, so they go away, and I'm left with millimeters of mercury, which is what I want. 74.1 times 760 divided by 101.3 equals 556 millimeters of mercury. Now I'm going to use my formula up here. My total pressure is going to equal my pressure of my helium plus my pressure of my oxygen plus my pressure of my xenon. I'm just going to go ahead and plug in all my stuff. So PT is equal to 972 is equal to the pressure of helium, which is 348, plus the pressure of oxygen, which is 556, plus the pressure of xenon. If I add these two together and subtract it from 972, I will get 68 millimeters of mercury as my pressure for my xenon. Now we also have over water test. It also deals with partial pressures. That's when we use this in the lab when we are creating a reaction that produces gas and we want to find out how much gas we have produced. We will put a tube in there to collect the gas, and then we put it underwater. And when we do that, it bubbles up into another tube, and we collect the gas there. Total pressure is the pressure of the gas plus the pressure of the water vapor. So an example calculation, we have 50 milliliters of hydrogen collected over water and has a pressure of 850 millimeters of mercury at 27 degrees C. What is the pressure of the dry gas? So our PT is equal to 850 millimeters of mercury. We have to have the pressure of our water, and we also have to have the pressure of our dry gas. So I'm just going to call that gas because we don't know what it is. The total pressure is the pressure of wet gas, by the way. Okay, so it doesn't give us the pressure of the water, but we have to have it. So we're going to use this 27 degrees C and come over here and look at water vapor pressure in torr. And by the way, a torr is equal to a millimeter of mercury. At 27 degrees, the water vapor pressure of just water is 26.7 millimeters of mercury. So we're not going to use this 50 milliliters of hydrogen. I would like for you to go ahead and take off. It says, what is the pressure of the dry gas at STP? We're not going to do that. We just need to, I just want you to figure out what the pressure of the dry gas is. Now let's plug this in. Our total pressure is 850 millimeters of mercury, so we don't have to change it, is equal to the pressure of the water, which is 26.7, plus the pressure of the gas. So if I subtract 26.7 from both sides, I'm going to get the pressure of my gas is equal to 850 subtracted from 26.7, and that is 823.3 millimeters of mercury. Thanks for watching.